Hello everyone. Today I'm excited to demonstrate the power of ClasHStamp, a powerful plugin for Change Vision Astah that enables code generation, real-time simulation, and test case generation from UML class and hierarchical state machine diagram. What you see here is a complete model of dashboard design. Model in Astah and powered by ClasHStamp simulation and generation engine. The beauty of this system is that it is not just a diagram. With one click, ClasHStamp generates C source code automatically from the model, including the full hierarchy of state machine, event handler, entry-exit actions, and etc. Please wait a moment for the code generation complete. Okay. You can see here, this generated code is clean, readable, and directly integrable into embedded system or test environment. You can see here that classes like car body and state machine regions like engine management. Here, gear system. Here, and display system. Here. Okay. And are translated into modular event-driven code like this. This ensures consistency between the design and implementation. What you model is what you run. Now, let's shift into the simulation view, which is fully interactive. Here on the screen, you see the dashboard's GUI, a car layout with functional controls, a power button to switch the car on and off, a gear up and down to simulate the shifting gears, a reverse button to switch to the reverse mode, an accelerator pressed, release to control the engine output. Each button triggers state transitions and you see the result reflected immediately, not just the dashboard display, but also in the state machine diagram and the real-time log. Let's begin by pressing the power button. The car transitions from the car off state to car on, and as you can see, the red border around the car off, meaning the car off state has exit, and three parallel regions inside the car on become active, each highlighted with green frames, including engine management system and gear system and display availability. This is ClasHStamp support for AND states, multiple state machine running in parallel. On the dashboard, you can see the dashboard lights turn on and the log at the bottom to confirm the state transition, including car off exit, enter the car on, and the gear system enter the park system, and The engine management has been entered, and after that, the engine idle. In the display system, with default, we enter the display availability. Now, let's explore some of the critical behavior constraint model in ClasHStamp. I press the accelerator while the gear is still in the park state. You can see nothing happens in the engine. The state remains in engine idle. The speedometer stays at 0. That's because in this model, acceleration is only allowed when the gear is engaged, either in drive or reverse. This constraint is embedded directly into the transition guard of the state machine. This level of modeling ensures no accidental state misbehavior, even under complex sequences. Now let's shift to the drive. The state machine transition from park, neutral, drive, and all inside the composite state gear engage. I press the accelerator again, and this time the engine transition to engine accel, and speedometer update, and the log show enter engine accel. This showcases correct logical gating acceleration is only possible when the car is in gear. Now I shift to drive to reverse. Okay. As soon as the gear enters the reverse state, inside the gear state, you notice the cross-region reaction. The display state switch from digital available to back camera, and the dashboard view updates and showing the rear camera as active. This kind of logic, where events in one region affect another, is handled using the synchronized inter-region transition, a key strength of ClasHStamp. Finally, let's leave the gear engage by shifting back to neutral or park. As soon as we exit the gear engage, the display region automatically transitions back to display available. Again, you see the green highlight, the diagram move, and the dashboard reflects this change. The rear camera's view disappears. And at the bottom, you see the event log window. It tracks all the state transition in the real time, make it ideal for debugging complex state behavior and testing edge cases and tracing internal logic during simulation. There's more important constraint in the system. Power off can only occur when the gear is in the park state. Let's say we try to press the power button while the car is in the neutral button, a neutral state. You can see nothing happens. The power off transition is guarded with a condition like gear is in park. This ensures that the car cannot be turned off unless it's in a completely safe and stationary condition, just like in a real-world automotive systems. Once we shift back to the park, the power button will work again. Okay, allowing us to transition from car on to car off safely. With ClasHStamp, we're gonna be on just modeling in Astah. We created a fully modeled control system with formal semantics, code generation that reflect your design, interactive simulation for validation, visual feedback to a 2D GUI dashboard, and a hierarchical and parallel state logic that mirrors the real-world embedded systems. Whether you design automotive ECU, embedded controller, or cyber-physical systems, ClasHStamp empower you to model once and deploy everywhere. On the next occasions, I will introduce a new feature of ClasHStamp, which helps you automatically generate a comprehensive set of test cases that cover all the behavior of the system. Thank you for watching.